Hi, I'm Shannon,
I'm Brisa.
and we were the 2021 TSS Conservation Scholars. So, what is conservation? Conservation is, quote, all actions aimed at the safeguarding of cultural property for the future, end quote, defined by the Canadian Association for Conservation.
The purpose of conservation is to study, record, retain, and restore culturally significant qualities of the cultural property with the least possible intervention.
This summer, we worked on two different projects.
One of which was the Northwest Coast Collection Grant, which was awarded to the Denver Museum of Nature and Science in 2020 and is comprised of 700 items from several different culture groups such as the Haida, Tlingit, Nuu-chah-nulth, Makah, and the Kwakwaka'wakw.
Normally, we get new artifacts from the grant every week and write condition reports on them, which assess their overall physical properties and determine how they should be treated.
One example of this would be a knife that belonged to the Tlingit people circa 1850 and was used by Chief Nanook of Telegraph Creek. The knife is made of ferrous steel as seen through a magnet test with a wooden handle decorated with animal faces and abalone shells etched into the facial features. There are also 14 marks etched into the heel of the blade, which signify the amount of people Chief Nanook killed in battle. One of the most important aspects of a condition report is assessing the damage of an object. For example, is animal skin, and it's obviously shown some signs of use. And the head over here has abalone shell etched into the features, and it's embedded more so on one side than the other, the front side to be specific. But there are some missing, and you can see that by the portions that are carved, and there are broken bits, and there's a split on the eye of the top animal that's placed on top of the bigger one.
It is also important for us to recognize and identify what the carvings, markings, or drawings on the object represent for these groups culturally. For example, this headdress from the indigenous peoples of Kwakwaka'wakw depicts some type of eagle from general glance, but it actually symbolizes Thunderbird, an ancestral sky being that is believed to cause lightning when its feathers ruffle and thunder when its eyes blink. The two faces on the front and back depict Siskiyutl, a powerful double-headed serpent that represents power and invulnerability. Like the Tlingit knife, the headdress also shows obvious signs of use and wear, from the tarnished copper horns to the discolored headcloth covering the band's inside.
Of course, a visual is needed to really depict the condition of these objects. After thoroughly writing a condition report, we head to the photo studio to take shots of all angles and close-ups of any extensive damage there may be.
When there is notable damage or vulnerabilities, we put the object under a microscope and photograph any deterioration below the surface. All of this is done before we process and color correct the pictures so that any future owner or organization can see the condition of artifacts when we had them in our possession in extensive detail.
We also focused on the Snowmass Cones project, in which 10 years ago, the Denver Museum of Nature and Science excavated an array of plant and animal life that had been waterlogged and preserved ranging from 130,000 to 70,000 years ago. There were approximately 315 partial and complete Douglas fir and Engelmann spruce cones found and stored in jars of water. As part of this project, we go down to pest mitigation, where our treated cones are stored in the freezer. Occasionally, opening up those doors will get us a lovely glimpse of the dead birds from zoology, but our real objective is to retrieve them for a biweekly observation.
The purpose of this project is to find the correct solution that would provide structure to the cones, to prevent the breakdown of the cellulose and cellular wall by experimenting with modern test cones before applying a method to the real cones. The bulking agents used were chitosan, which is ground up shellfish shells, sucrose, which is table sugar, and different levels of polyethylene glycol, or PEG for short. The ideal result would be that the cones are stable in air and retain as much of their original properties, such as color and texture, as possible.
In order to assure that we meet our objective, we catalog any changes to the cones in a 2-week period. We record quantitative data, or in other words, the weight of the cones, and qualitative data, which outlines any changes to the phenotype of the cone. For example,
It is a medium brown, no sloughing, scales are slightly open, There's no discoloration and a few cracks on the scales.
At times, the changes are negligible. Other times, large, irregularly shaped crystals appear, which show that a particular solution should not be used on the actual cones. When these changes occur, we put scales under the SEM in order to get a better look at the effects of the solution at a microscopic scale. For example, an image like this has the power to differentiate whether or not the solution went all the way through to the cellular level. During our 6 weeks here, we've gained skills that will not only assist us with building relationships and adaptability in the workplace, but also in life.
We are so grateful to have been given this opportunity to represent GMNS as teen science scholars. Thank you for your time.